All right, so we're doing a little bit of help for scientific notation. We have how many times larger is this value compared to this value? So we know this divides by 10 twice, and this divides by 10 8 times, so this is going to be a smaller number. But here's the trick when we solve values like this. Assuming that the first number, like the value taken to scientific notation, is larger on top, we can start by just doing the division of like 6 divided by 2. Now, fortunately here, that part's easier. Like it comes out to be a nice number. Then we can look at the tens. Now, the division of exponent values that have the same base. So remember, 10 is our base because it's the thing taken to the power. So since our bases are the same, we can combine the exponents through subtraction. So a good reminder on this is like if we had 10 to the 5th over 10 to the 2nd, what would that give us? It would be 10 to the 3rd because we have more 10s on top than we do on bottom. So what we have here is times 10 to the -2 minus -8 because we subtract when there's division happening. So -2 minus -8, that's actually going to become -2 plus 8, which is actually going to become 6, right? So this will give us 3 times 10 to the 6th power, because -2 plus 8, that gives us 6. So 6 times 10 to the -2nd is, now this still is kind of weird to talk about, so let's write it out in standard form. 1, 2, 3, 4, 5, 6. The first, this is a decimal, the first number they gave us is 3 million times as large as the second number. Now, we're talking about like microscopic values, depending on what our unit is, right? We don't know a unit here, but this, 6 times 10 to the -2nd, our first number here, this decimal would move left 2 places if we try to write it in standard form. So that's this in standard form. 6 times 10 to the -2nd, we move the decimal left 2 places. This is 600ths. So imagine if that was like 600ths of a millimeter, like if we were working in science. That's tiny. That's like, you can put your fingers together and like, if you don't press too hard, like, you know what I mean? It's like a tiny distance. This, 2 times 10 to the -8th, is that number. So that's why when we're comparing them, literally the first number we have is 3 million times as large, even though they're both tiny. This value is 3 million times as large as this value. Does that make a bit more sense now? So then it's easier when we compare really big numbers. Like here, let me pull another one. I'm going to pause my video to make sure I don't share any. All right, so then the next problem, working in positive powers, said this large number, 9 times 10 to the 7th, is how many times larger than 3 times 10 to the 3rd? So again, what we do is set up that comparison through division. So 9 times 10 to the 7th, 3 times 10 to the 3rd. So again, it's nice that 9 and 3 work out with a nice division. That will give us 3. But then times 10 to the what power? Again, we said we subtract when we have the division. So we get times 10 to the 4th. Because in reality, this number is 9, 1, 2, 3, 4, 5, 6, 7. That's 90 million divided by 1, 2, 3. It's 90 million divided by 3,000 is what we're actually doing. The answer that we got, 3 times 10 to the 4th, is 30,000. Right? So instead of having to write these numbers out in standard form, we can just work in scientific notation.